Welcome to the information session on enhancements in RapidPlan version 15.5. I'm excited to share the enhancements that have been made to RapidPlan in version 15.5. The objective is that in the next few minutes, you will learn all about the changes and make use of this information to transition smoothly to version 15.5. Many changes have been implemented in RapidPlan version 15.5. Here is a list of these enhancements. In the next few minutes, we will explore each of these areas. RapidPlan version 15.5 now supports a maximum of 10 model targets. This may be useful for complex plans that have more than 3 targets. The plan targets can be matched to the single model target, and the target dose levels can be defined in optimization. Additional model targets only need to be created if unique target objectives are desired per target dose level, or in the case of a simultaneous in-field boost where the target dose distributions are qualitatively different. Note that the fewer the model targets, the faster the statistics are accumulated, potentially decreasing the need for a larger training set. When a plan is added to the model and data is extracted, the DVH estimation algorithm was modified in version 15.5 to extract the target dose values for all the structures of a plan that are mapped to a target in the RapidPlan model. When adding a new plan to a model, the plan target structure gets the plan prescription dose as the default target dose value, but only if the plan target is automatically mapped to a target in the model. All other target dose values are initially empty. If the plan target cannot be automatically mapped to a model target, but is manually mapped in the dialog, then the initial value for the target dose is empty. The target dose is shown only for structures that are mapped to a target in the model. All target dose values need to have valid values for the plan to be added to the model. If the plan already exists in the model and the plan is being added again, the target dose values of structures mapped to a target are retrieved from the model and populated in the dialog. In this case, when adding a plan to a model, the PTV was not matched automatically and had to be matched manually. Thus, the target dose level has to be inserted manually by the user. In the alternate case, the PTV high was matched automatically and received the prescription dose as the target dose level. Let's take a look at what this looks like in the software. In external beam planning, we are going to add this plan to an existing RapidPlan model. Notice that the PTV in the plan is matched automatically to the PTV in the model, and the dose level is automatically populated with the prescription dose. In an alternate case, we will add this different plan to the same RapidPlan model, but in this case, the target was not automatically matched and is matched manually to the model target, and in this case, the dose level remains empty and has to be populated manually by the user. So you need to add the dose level manually when the target is not matched automatically. If you upgrade a model to version 15.5 by either extracting or training the model, the structure matching dialog changes in model configuration. The structure matching dialog in model configuration workspace shows the target dose values as missing for plants that were added to the model prior to the change in version 15.5. Any change in the structure matching requires the user to input the target dose values. If the user wants to extract or train the older version model in 15.5, the user will need to either deselect these targets or add the correct dose levels. It is recommended, but not mandatory, to input target dose values to the target structure mappings of the existing models. Such mixed models that do not have target doses specified for all plants are still supported. Previously, when a structure ID was modified in a model, in model configuration, the extracted data in model configuration was lost and re-extraction was necessary. Now with models created in version 15.5, model binaries use abstract model structure references, so changing structure IDs does not cause the extracted data to be lost. New in version 15.5 model configuration is the option to select either a target preferring line objective or an OAR preferring line objective. Previously, when an OAR overlapped with target, the line objective always preferred the target in the overlap areas. Now, the user can define the new OAR preferring line objective, which favors the OAR in the overlap region for the target. Let's see where we would select these options in model configuration. In previous versions of the DVH estimation algorithm, the overlap area estimates of an OAR with the target was modeled by using a means and standard model of the joint overlap DVHs of the OAR. The joint overlap DVHs refers to the DVH of the part in which the OAR is overlapping with any of the model targets. In cases when there were several model targets, this estimate was very wide. To address this issue, the overlap region is divided into several subregions, one for each model target. Each of the new regions is modeled by their own means and standard model. Each single target subregion is scaled by the target dose level. In this way, the overlap of an OAR with each model target is calculated independently, resulting in more accurate estimates in this region of the OAR. Small structure handling is better supported in version 15.5. The algorithms prior to 15.5 used a resolution of 2.5 millimeters. Thus, during the extraction phase, the algorithm would skip any structure that was half a voxel or less in size. Any skipped structure was not used for training the model nor recorded. The DVH estimation may not have been possible or not successful for very small structures in the past. Now in version 15.5, all the voxels of the structure, including those in which the structure occupies less than half a voxel, are considered in the calculation. The DVH estimation may not have been possible or not successful for very small structures in the past. Now in version 15.5, all the voxels of the structure, including those in which the structure occupies less than half a voxel, are considered in the calculation. The resolution set by the user is used. Note, this improvement is only used during re-extraction of older models and model applying with the new algorithm. The DVH estimation structures may also vary depending on the structure resolution. The principal component analysis during the training phase of the model has changed. DVH and geometrically expected DVH parametrization is based on principal component analysis. The RapidPlan algorithm finds curves that represent the variation of individual DVHs compared to the mean curve. For small structures, typical DVHs are close to a step function requiring multiple principal components to present variable location of the step. Therefore, presenting variations from the mean curve requires multiple PCs. Since DVHs and cumulative volume histograms for the geometrical expected dose are monotonically decreasing functions, they can be replaced by their inverse functions, functions of volume rather than dose. These two different interpretations would lead to different principal components, often one of them being more natural than the other. Thus, the PCA regression model is trained separately using both interpretations. The model with a better coefficient of determination is selected by the system. Small structures typically benefit when the principal component analysis is made based on inverse DVHs. In practice, principal component analysis based on inverse DVHs is beneficial for small structures having step function type DVHs and for structures where the DVHs hit zero in different locations as depicted here. The artificial long foot in the estimates of the quickly falling curves is also reduced using the method of principal component analysis. The model binary format has changed in version 15.5. Therefore, algorithms from previous versions cannot use models trained with version 15.5 algorithms. For example, you cannot use DVH estimation 13.7 in optimization with a model created in version 15.5. The model configuration workspace supports DVH estimation algorithm 15.5 only, whereas photon optimization supports two versions of the DVH estimation algorithm, version 15.5 and the previous version. RapidPlan models created on a previous version of the DVH estimation algorithm are supported and can be used with the DVH estimation version 15.5 algorithm. However, they should be revalidated if DVH estimation 15.5 is used in photon optimization. Existing RapidPlan models need to be re-extracted, retrained, re-verified, and revalidated to include fixed issues and new features. Any models exported from model configuration version 15.5 are converted to the new format for version 15.5 regardless of their original version, such as 13.6 or 15.1. 15.5 models can only be imported into model configuration version 15.5. They cannot be imported and work in previous versions. If you are upgrading to version 15.5 and wish to share your models with users on model configuration versions prior to 15.5, it is recommended to back up all previous models by exporting them out prior to your upgrade. This concludes the training session on new features in RapidPlan version 15.5. If you have further questions, please contact the Varian Help Desk. Thank you for your attention.